So my name is Marc Macias-Fauria, and I'm an associate professor in physical geography at the University of Oxford. And my main research question is basically to study how ecological systems work, with a strong focus on both vegetation and also cold places. Many times it's the Arctic, but sometimes it's the alpine areas as well, in mostly across the northern hemisphere. And I have focused a lot on vegetation change, not only in the recent past using remote sensing and observational data, but also in the deeper past. It's not deep time, because geologists use deep time to refer to millions of years, but it is the last 10 to 15,000 years that I've been interested in. To look at, of course, we don't have observations, right, beyond the last few decades, sometimes few centuries if we are lucky. So we need to resort to what we call environmental proxies. And proxy is basically, if you're dealing with ecological processes, it will probably be a remain that gives you information of past life activity. Many times these are fossils or subfossils. We call them subfossils because they are not real fossils. In the last 10,000 years, you don't have the full fossilization, so that you're actually studying stones and mineralized remains, but you're actually still studying organic matter that used to be alive and that we can find in the bottom of lake sediments, or in the Arctic, because the Arctic is so cold and dry. Sometimes you just find the remains on the ground. Work Package 4 is the package that actually opens the door to the deeper time in the Charter project. So it tries to understand changes in biodiversity and ecological processes in the Arctic area for the last centuries to millennia, for the last hundreds of years to a few thousand years. And to do that, it will compile all the data available that we can find in the literature and in other sources that gives you information about this variability of ecological systems through the deeper time, with a focus on the last 2,000 years. And this focus is justified because, first of all, we have more data. The more towards the recent we explore the past, and also because this is roughly the time in which reindeer were domesticated and reindeer herding started. So one key question of Charter, but also of Work Package 4, is to link reindeer herding with changes in the environment, right? So we are going to focus particularly on areas in which there has been reindeer husbandry for a long period of time, mostly northwestern Eurasia, from Yamal to Fennoscandia. But we're not going to stop there. We're going to try to create a data set for the whole of the Arctic using already existing data. Then the Charter partners, we have our own data from key regions that we have been working on over the last, in some cases, decades, in some other cases, several years. And these key regions are northern Fennoscandia, Lapland, Yamal, but also other places such as Greenland, where some key members of the Work Package have been collecting long time series of vegetation dynamics and change, which span several centuries. In terms of data collection, the expertise of the consortium that comprises Charter in any particular Work Package 4 has produced a lot of data, much of which is not yet published because it's quite fresh and it's being curated and analyzed. A huge part of Work Package 4 is to actually put this data together and analyze it for the first time, but not to collect it because it was collected in the previous years, The collection of new data is going to be limited to places where we identify that we really need data in order to advance our questions. Another component of the data collection of the Work Package 4 is to basically analyze or study what other type of data that was not compiled or produced by our members, but that has been produced by the Arctic community at large, exists on past environmental change for the Arctic, and produce a database that's going to be open source. So we're going to analyze that data, but we're also going to create a repository of data that's going to be focused on the Arctic. It will take it will take all sorts of proxies, as I was mentioning before, of biological remains that tell us information about past ecological activities, and it will put them together in one repository that will be open source, in the sense that other researchers, once Charter is finished and has analyzed all this data, will also be able to use. The data on the Russian side is more difficult to access for two reasons. One is because we are not Russian, and the Western science has had traditionally difficulties in accessing that data, and the other is because Russian science in many cases hasn't made the effort of actually compiling all this data and putting it in a repository. So a lot of data remains fragmented not in digital copies, but in physical copies, paper publications in libraries, etc. So in this aspect, it is extremely important to actually have Russian partners, which we do have, to open up that large gap that many times, from the Western science point of view, we are talking about Pan-Arctic, and many times, you are probably familiar. They show you the map of the Arctic, and they say this is a Pan-Arctic study, and there is one point in Russia, or even sometimes not even one. So definitely a big effort on this Pan-Arctic compilation of data is going to be to open that source of data and incorporate it into much more easily accessible data that would come from Greenland, Western Europe, and North America. It is ambitious, but at the same time, we're not starting from zero. Mm-hmm. So there is existing repositories which are not focused on the Arctic, from which we can take big chunks of data and customize them into our particular target area. And these data sources are there, and they have made an effort before us to compile a lot of what we call paleoecological data and paleoenvironmental data, but not with the Arctic in mind. So I think that the most ambitious component of this first step of producing a Pan-Arctic database on biodiversity is the Russian aspect of it, and that is an area that we will have to make a very concerted effort. The non-Russian aspect of it, although there is going to be a lot of records that might not be compiled already in other data sets, we're going to start from a stage which is not the stage of looking at individual work, but actually accessing data sets that already exist and adapting them to our objectives. So in this aspect, it might look ambitious, but it's not crazy ambitious, or we hope so. The fieldwork component of Charter is going to be mostly occupied by other work packages, and the fieldwork component of Work Package 4 is going to be very limited to the target regions, namely Yamal and Northern Fennoscandia, and for target proxies that we identify as essential in order for us to fill gaps that will emerge from the data that already exists. So in this aspect, the fieldwork component of Work Package 4 in Charter is a minor component of the work package. Mm-hmm. Our work package is going to be pretty much focused on a big part into compiling already existing data, analyzing it for the first time. And I didn't mention this before, but one of the key objectives of this work package is to understand how the ecological systems and the environment has changed in the past as a response of changes in climate and changes in external factors to the biological systems. So in this aspect, we want to test whether we can find in the past situations where changes in climate produced given responses of Arctic ecosystems that we can learn from in the obvious present environment of very fast paces of change in both climates and other environmental factors such as ice-related ones, cryospheric processes, permafrost melt, sea ice changes, changes in the nature of the precipitation from snow to rain, etc., etc. Well, the first thing that has happened is that the project should have started by now, and it hasn't yet. So we are delayed, and that is probably a blessing, because given the chaos that followed the lockdowns in different countries as they started at around March, it would have been impossible to actually keep up with the originally planned schedule for the project. So first thing that has happened is that there has been a few months delay on the start of the project. Because of what I was telling you, Work Package 4 in particular is not particularly vulnerable to a delay in fieldwork opportunities, because we have a lot of work to do with existing data sets, as what we would call it desktop-based research. So in this aspect, we're planning to start in as early as August, if not September, compiling this data and making sure that we have a structure for our data set, that it's easily accessible and easily analyzable. So in this aspect, other components of the charter project are much more deeply affected by the delay, because this delay has encroached into the field season, and in many cases has prevented field season to start in time. Given the nature of our work package, that hasn't been such an important limiting factor for us. So the very first one is to put the current changes in a longer framework, in a longer perspective. So one problem we have in general with Earth system science, as we call it, or this large scale research, which, let's say, focuses on study units which are huge, such as the Arctic or the Earth as a whole, or Asia, or a given very large system, is that we cannot just have an experimental setup in which we have little Arctics, and in this one it's going to change this way, and in this one we're going to put this particular developmental line, etc., etc. But what we have is one non-replicable Arctic, which is changing. The beauty of analyzing the past is that this one system has changed in the past to drivers. Some of them might have some analogy to changes that are occurring now. Some of them might not, but at the very least, we are providing a comprehensive view of how the Arctic has responded, the Arctic ecology, but not only ecology, because of course, if we are focusing on reindeer populations, we are focusing on key components of social ecological systems as well, has responded in the past to stressors or to drivers of change that have occurred. So in this aspect, the first fundamental thing we provide is this longer term perspective, in which we can interrogate the paleo record and say, when things went this way in the past, what happened? What did vegetation do? What did these animals do when it got warmer, or when sea ice vanished for a period of time, or et cetera, et cetera. So in this aspect, that's point number one. Point number two, which I find increasingly fascinating, and remember, I am a biologist, so I've come to human nature interactions as I have progressed in my career and research, but I initially started with a focus which was much more focused on what plants do, and I wouldn't really think too much in who lives there. But one particularly interesting and fascinating aspect of charter is the consideration of the systems that we are studying as social ecological systems. And in particular, with respect to reindeer herding, the emergence of reindeer herding, but also the management of these large herds especially in northwestern Eurasia, the question is, how have these herds and this herbivory shaped the responses of Arctic nature in times of environmental change, and is this human agency increasing, decreasing, or modifying the resilience of these systems or of these natural systems in times of change? So this would be a second fundamental question, which we aim at putting in this longer term perspective again, so that we are not just analyzing the last 3 decades, for which we have some sites in which some researchers have been operating and painstakingly producing observational data, but we have a much deeper time frame over which we can analyze these things. This comes at a cost, and the cost is that we're analyzing indirect sources of information. That's why we call them proxy. And this cost means that we don't have the depth and the precision that we could get from observational data, but it comes with the advantage that we have many Arctics, in a way, if you want to kind of think about it that way, which have responded to changes in the past that we are very interested in understanding, because they might give us information about what happens now. I could give you 2 answers. The first answer is the least professional one, which is that I've always been fascinated by these vast expanses of, from my childhood in Barcelona, in a Mediterranean city, which is heavily, densely packed. The Arctic to me was a largely empty, vast wilderness that I wanted to explore. As I got the chance to visit it, I realized that it's not remote and it's not empty, but it's the home of people. And much of what happens there is actually related with the fact that people have been living and acting there for centuries and millennia. So that has been a learning process, right? But that could be the non-professional one, this irresistible attraction to the far north, which probably was linked with my love to the Pyrenees, which are the mountains that we have behind Barcelona, which have that's where we get our dose of cold and snow and north that's my memory from childhood. From a professional point of view, I've always been very fascinated by the way in which biological systems are inherently constrained by the physical characteristics of the system in which they live. And the Arctic in this aspect struck me as a very naked system, where it is very obvious that the physical environment is controlling and interacting very clearly with whatever is living there. So in this aspect, I was interested in the Arctic as a system where this signal would be very clear. You're having the geology, the permafrost, the climate, these extremely cold, long winters, the extreme seasonality of light and temperatures. This has to be driving ecological systems. If you compare that with a tropical rainforest, in a tropical rainforest, you have the feeling that it is life itself that's organizing things. And you have this seemingly stable, prone to life climate that basically has allowed this incredible complexity to evolve. Whereas in the Arctic, I could see the opposite. I could see life striving to actually cope with these very demanding physical conditions. My specialty, I call it biogeosciences, and it really gives a lot of weight to the physical environment. And that's probably one of the main reasons why I'm very attracted to the Arctic, because of this coupling being very evident in this system.